We're going to start a unit today on scientific notation. If we go straight to our vocabulary here, scientific notation is a compact way of writing numbers with absolute values that are very large or very small. So we have these really small numbers that have a lot of zeros in them after the decimal, or these really big numbers that have a lot of zeros after them. And a lot of times you'll see those in science, like if you talk about the distance between galaxies, or as a really large number, or a really small number might be like the size of an atom or something like that. And if you're going to be using those numbers a lot, it's nice to have a more compact way of writing them. So that's called scientific notation. So go ahead and fill that in here for your vocabulary term. Our objective today is I can convert numbers between scientific notation and standard form. Standard form is the way we normally write numbers. So today we're talking about going back and forth between those two forms. So let's go straight to the first skill here, which is, it says write each number in standard form. Go ahead and draw a line to separate these two sides, but don't draw through the words there. So we're going to do example A here. This is what a number in scientific notation looks like. We have some number here that's between 1 and 10. And then that's going to be multiplied times some power of 10. So this is 10 to the 7th power. So 10 to the 7th power is, I think, 10 million. So this is 5.6 times 10 million. But it's a more compact way of writing what that would equal. But we're going to write that in standard form now to see what that looked like. So here are the steps. There's just two of them. We're going to move the decimal point, the number of spaces indicated by the exponent right here. So for positive exponents, we're going to make this a larger number, so we're going to move to the right. And for negative exponents, we're going to move to the left. So go ahead and rewrite this is called the coefficient, this number right here that we multiply times the power of 10, so 5.6. And because we're multiplying times a positive exponent, we're going to move this decimal, the number of spaces indicated by the exponent. In other words, 7 spaces. We're going to go 1, 2, 3, 4, 5, 6, 7. And to complete this number here, we're going to have to rewrite the number here, filling in the empty spaces with zeros. So go ahead and fill in all of our empty spaces with zeros. And notice that there are not 7 zeros. We moved 7 spaces, but one of those spaces was taken up by this 6 here. So you can't just fill in this as your number of zeros. That's how many spaces you move. So go ahead and rewrite this. This is 5, 6, and then there's 1, 2, 3, 4, 5, 6 zeros. 6 zeros. Then we'll put our commas in. If you remember, we start all the way here on the right. We count 1, 2, 3, put a comma, 1, 2, 3, put a comma. So this is 56 million. And that makes sense because we're multiplying 5.6 times 10 million. So we got something in the 10 millions there. 56 million is in the 10 millions. Let's go ahead and do example B here. Go ahead and rewrite 7.21 here underneath there. And because this is a negative exponent, remember we talked about how negative exponents don't give you negative numbers, they give you very small numbers. So we're going to make this number less than it is right now here where the decimal is. We're going to move it to the left 6 spaces indicated by the exponent there. So 1, 2, 3, 4, 5, 6. And then we fill in these empty spaces with zeros. Once again, you notice that we did not fill in 6 zeros. We moved 6 spaces, and one of those spaces was taken up by the 7 already. So we just have 5 zeros. 1, 2, 3, 4, 5 zeros, 7, 2, 1. This is a very small number. It's not a negative number. It's a number that is very close to 0, but not quite 0. It's still worth something. Okay, let's go the other direction here with this now. We're going to take numbers that are in standard form, and we're going to write them in scientific notation. So go ahead and, again, let's split this down the middle here. We have 2 different examples we're looking at. So it says write each number in scientific notation. So the first is to move the decimal point until it's after the first non-zero digit. So as you go from left to right and you look at this number, we want our decimal to end up after this first digit that's not a 0, to create a number between 1 and 10, basically. Because scientific notation, it has to be a number between 1 and 10 listed here first. See, 5.6 is between 1 and 10, 7.21 is. So we have to move that decimal until it's where it needs to be there after that first digit that's not a 0. So right now in this number there is no decimal point. So when there is no decimal written, it's all the way over here to the right. So we're going to move it until it ends up where it's supposed to be, between the 8 and the 2. So 1, 2, 3, 4, 5, 6, 7. I moved it 8 spaces. So we're going to go ahead and rewrite our coefficient as 8.29. Let's do this down here. 8.29. I don't need all those zeros anymore. Scientific notation is always times 10 to some power. It says if the original number was a large number, then we're going to make the exponent positive, and if it was a small number, make it negative. And the exponent that we're going to write here is just the number of spaces that we moved. We moved 8 spaces. We know this was originally a very large number, something in the 100 millions. So we're going to go ahead and multiply it times 8 there, okay? So times 10 to the 8th, excuse me. So if it's a large number like that, it's a positive exponent. For this next one here, our original number is a very small number. We're still going to move until we end up 1 after the first non-zero digit there, right there. So we're going to go 1, 2, 3, 4, 5, 6, 7 spaces right there. So this is going to be 3.1 times 10, either to the positive 7 or negative 7. But because this was originally a very small number, we know it has to be a negative exponent. So times 10 to the negative 7th power. So let's do a little more work with this here. Flip over to the back. And we're gonna do these. I think we'll talk about these in class. So why don't we just go ahead and go down to these problems down here, and we'll do some of these together where we're just practicing this skill. And we'll talk about comparing numbers in scientific notation in class. So it says write each number in standard form. So the first one here is going to be a number in scientific notation, 5.34 times 10 to the 4th. So the first thing is just to rewrite the coefficient here, 5.34. We're going to be moving the decimal 4 spaces, because that's what's indicated by the exponent there. And because this is a positive exponent, we know we're going to make this a large number, so we're going to move to the right to make it a large number. So 1, 2, 3, 4. And we're going to fill in those empty spaces with zeros. This is 5, 3, 4, 0, 0. So we put 1, 2, 3, comma right there, 53,400 for that first one. Number 2, we're going to write as, we're going to do 6.02 times 10 to the negative 4th power. So we're going to write, this time it's a negative 4, so it's 6.02. We're going to move this decimal 4 spaces, but this time to the left, because we're going to make this a smaller number than it used to be, or a smaller number than the coefficient is. We're going to make it less. We're going to go 1, 2, 3, 4 spaces. 1, 2, 3, 3 spaces get filled in with zeros there, so 1, 2, 3, 6, 0, 2. So positive exponents move to the right, negative exponents move to the left. Instead of trying to remember right and left, a lot of times I just look at the number and say, is it supposed to end up as a large number because I have a positive exponent, or is it supposed to end up as a small number because I have a negative exponent? And I just move the decimal the correct way according to if it's supposed to end up large or small. Okay, the next one is 7.32 times 10 to the 6th. So rewrite 7.32. We're going to move the decimal 6 spaces. Because it's a positive exponent, we'll make this a large number. So we're going to move it 1, 2, 3, 4, 5, 6 spaces to the right. Fill in those empty spaces with zeros and rewrite your number. I'll do it down here. 732, 1, 2, 3, 4. Comma, comma. That makes sense. 10 to the 6th, 10 times itself 6 times is 1 million. So we're taking basically 7 something times 1 million. So we got 7 million something, 7,320,000. Okay, we'll do these in class here. So let's just practice this, writing each number in standard form. Now we're going to give some numbers in scientific notation. You're going to have to write them in standard form. So the first one here is 7.42 times 10 to the 5th. So once again, we go ahead. Oh, we're going to write each number in standard form. I'm sorry, we're gonna do numbers in standard form, and we're gonna go to scientific notation. So actually, we meant to do these here first. So we're gonna do standard form and then scientific notation. So we're going to be doing 3,720,000, and we're going to write that number in scientific notation. So we're going to, if there's no decimal already, we're going to put it here, and we're going to move that decimal over until it's directly to after the first digit that's not a 0. So basically, remember, we're creating a number between 1 and 10 when we do this. So we're going to go 1, 2, 3, 4, 5, 6 spaces, and we end up with 3.72. See, 3.72 is a number between 1 and 10 times 10 to the, and we moved 1, 2, 3, 4, 5, 6 spaces. So it's going to be an exponent of either positive 6 or negative 6, because this was originally a large number. It's going to be a positive 6. So 3.72 times 10 to the positive 6th power. All right, the next one is 277,000. Okay, again, if there's no decimal on here already, we put it right there all the way to the right. And again, we want to move it until it's directly after the first digit that's not a 0. As we look at the number from left to right, it should come right after this 2 right there. So right now we got to move it 1, 2, 3, 4, 5 spaces, 2.77 times 10 to the, and once again, this is a large number, so it's going to be positive 5. Positive exponents are associated with large numbers. Negative exponents are associated with really small numbers. So let's do one more here. 0.000316. So again, the decimal, we're going to have to move the other direction this time. It should come after this first digit that's not a 0, between the 3 and the 1 here. So we're going 1, 2, 3, 4 spaces. And now our coefficient's going to be 3.16. And it's always times 10 to some power. This is going to be 10 to the, because we moved 4 spaces. It's going to be either positive 4 or negative 4, and because this was originally a very small number, it's going to be to the negative 4th power. So we're going to do the on-your-own problems in class. We'll also talk about this part up here. We're putting numbers in order in scientific notation, because you have to do some of that as well. But this is just an introduction of going between the two different forms, between scientific notation and standard form.